What's up, gangsters? It is time for a video. A video about how to do something, or an intro about how to do something, and what will probably be my least watched video ever. So, why do a video introduction to Fusion 360? And if you're not familiar, what is Fusion 360 in the first place? Okay, let me get to all that. You'd have to pretty much have been living under a rock for the last 5 or 10 years to not have heard of 3D printing. It's the it technology, and lots of people have talked about how it applies to scale modeling. You'll even see people talking about how it's going to replace injection molded kits. Well, as I've talked about in the past, that is just simply not going to happen, at least not anytime soon, and not without some kind of a major technological miracle, where we're suddenly able to start pushing things around at the molecular level. 3D printing just can't compete with injection molding in terms of resolution and surface finish. But where it is obviously applicable is in situations where you can't get the parts that you need any other way. Nobody makes them in resin. They don't come with any injection molded kit. You might be able to scratch build them, but that's assuming you have the skill and the time. So from that perspective, 3D printing is a really powerful tool in the scale modeling arsenal. And over the last few years, it's the level of technology that makes that true has become a lot better. I mean, 5 years ago, to get anything that could really compete or really made sense for creating custom parts that had to be really well detailed and have really good resolution, you needed to spend $5,000 at a minimum on something like a Form 2, which is an SLA machine. And I'm not going to get into all the details about the different technology, but SLA is the technology for us. But a couple of years ago, a company called Anycubic came out with a machine called the Photon. And the Photon is basically about the size of a blender. It goes on your desk, and you can do amazing stuff with the thing. I've shown some parts in some of my videos that I've been getting lately that really are incredible in terms of the resolution, the surface finish, the size. I mean, things like little bitty tiny 1/24th scale bolts and hose clamps or hose fittings. Stuff like that that's just really, really cool and really difficult to scratch build, honestly. So from that perspective, the 3D printing part of it has become really, really accessible at a level that really is starting to become very useful for us. But what most people overlook, most people don't really take into account, is that there has to be a digital database somewhere in order for those parts to be 3D printed. Somebody has to do the modeling digitally using either a basic surface modeling package like ZBrush or Rhino or Blender, or it has to be done in a CAD package, computer-aided design. And my experience is with the CAD end of it. Back in my corporate days, my first job as an engineer, I spent a lot of time in front of a tube using a software package called Pro Engineer. And I also used SolidWorks some. Now, Pro Engineer and SolidWorks are both enterprise level computer-aided design packages, and at the time anyway, Pro Engineer, you could spend $100,000 on it, and it had to run on a Unix workstation. It was not at all accessible to the everyman. SolidWorks, even at that time, was $5,000 a seat. And there are lots of other packages. But again, until recently, none of them have been as powerful and as accessible to us as we really need them to be for them to be useful. There were things like FreeCAD and Tinkercad, both of which I've messed with, and which, quite frankly, I found to be terrible. So Fusion 360, which is made by Autodesk, they're the same people that have made AutoCAD, Inventor. Fusion 360 is fully functional, for one thing. It's basically got all the same capabilities that something like SolidWorks has. And I don't know of anything really that we would want to do that it can't do. It's not really designed for freeform surface modeling. So if you wanted to build, for example, a three-dimensional model of a person, you'd want to use something more like ZBrush. But for engineered parts, the kind of mechanical components that are found on vehicles that we build models of, a parametric CAD package really is the ideal thing. And in my opinion, it's easier to learn to use. That's why I find Fusion 360 to be compelling from a fundamental level. But here's the really cool thing about 360. Autodesk has made it available for free. That's right, you heard correctly. If you are a hobbyist or a startup business that produces less than $100,000 a year, you can get a license from Autodesk to run Fusion 360 for zero money. It's fantastic. You update once a year, that's really all you have to do. And they are not showing any signs of discontinuing that, so it's great. Now the next question you might ask is, but wait a minute, what about the computer to run it on? Because that did used to be a pretty significant issue. In the past, you had to, at a minimum, have a pretty powerful Windows machine to run any kind of CAD software on. Fusion 360 solves that. I run it on my iMac, and it works just fine. And the reason that it can do that is because it's basically a web-based app. And so you do have to do a download to make it work on your system, but that's just basically so that it can stay connected with the app on the internet. So it's fantastic. I can't believe how cool and easy it is for me to be able to engineer parts that I want on a Mac at my desktop for free. So I know that this is not going to apply to a ton of you, but if you are at all interested in creating your own parts and having them 3D printed, hopefully this has piqued your interest at this point. And what I want to do with this video is just give you a basic overview of how you do that, how you create parts within a parametric design software like Fusion 360. So, without further sales pitch on my effort, let's get right to it. Okay, so let's give this a whirl. Let me first show you some parts that I've already built and that I've talked about on my YouTube channel, so some of you might be familiar with them. This project is for my Tamiya 1/6 scale Honda Monkey. And there are quite a few parts that I wanted to customize. Not only did I not like the kit parts, but I wanted to create something totally different. So that's what's happening here. And what you see in front of you is an assembly of all the parts that I've created. And they are basically referenced in space according to this reference photograph. And this is one of the cool things that you can do with Fusion 360 is you can import a JPEG of whatever it is that you're trying to create a model of or to use as a reference like I've done, and calibrate it to the correct size, and then do your modeling around that. And that's basically what I've done. Now, an assembly is basically just a collection of individual parts. So you can see, if I zoom in here, you can see that there's quite a few parts here. Fork tubes, triple clamp, lower triple clamp, fork bolsters, handlebars, grips, and you can see all of those individual parts over here. And so basically what happens is you design each part. Well, there's two ways to do it. One way is to design the parts individually and then join them in the assembly later. And that's a pretty straightforward way of doing it. I'm not going to get into showing you how to create an assembly with this quick overview, but just suffice it to say that what you do is you make these little references. Like you can see right here, I've got got a funny message from John Geigel. He runs Masterpiece Models, and we text back and forth, and I'm not going to read whatever it was he wrote there, something about lotion. That might be embarrassing. Anyway, you can see that there's a little reference point thing in here, that sort of happy mouth circle thing there. That's an assembly reference. And what will happen is you will mate that assembly reference with a similar assembly reference on the part that it's supposed to attach to, which in this case is the handlebar. So you can kind of see what's going on there. You just put the thing together the way that it normally would go together, and you put those mate references in there such that the parts will join at the appropriate location. But that's a whole other subject. Don't want to get too sidetracked. I just wanted to show you guys how a collection of parts that you build works when you make it into an assembly. Now, the other way of modeling in an assembly is to actually create the assembly and model everything in situ. So basically, I would have had an assembly where I would have created, say, the handlebar. I would have created that first. Then I would have had reference points on the handlebar that would have allowed me to start building the grip component. And that can get a little bit more confusing. Not exactly what I would recommend for beginners. But again, assembly modeling is a separate subject, and that can be learned on one of the many YouTube videos that are available for Fusion 360. The bottom line is that it's not something that most of us as scale modelers are going to have to do a whole lot of. I did in this case with this project, because I was basically building the entire front end of this little motorcycle. And so I had a bunch of parts that were going to have to go together. But if I had just been building a single component, then I probably would have been able to just create it all by itself. And that's what I'm going to show you guys right now, how that basically gets done. So I'm going to go back over here to a folder that I've just created called Model Aircraft Fixture. This is a new project that I want to start on, and I need to close these things out here real quickly. Okay, and so what I'm going to do is basically I want to create a new component. So that's going to be a new design. And it doesn't have a name until I save it, which we'll do here momentarily. But this is the basic process of creating a part. And you have to know also that all the units and everything are already set up. Once you set, like for example, I'm modeling everything in millimeters, and those are already set, so I don't have to turn all that on each time that I want to do something. What I just did there was I turned on the origin. Okay, this is basically the point in space with an X, Y, and a Z axis, and you can see that up here, and that's going to reference the part. Now, if it's a standalone part, it's not super important where you start, but it's just good to have a consistent practice of how you model things. And I always do it, looking at the thing the way that it would appear naturally. So what I want to make is a little L-shaped bracket. And so what I have to do first, and this is the way you create all parts in Fusion 360, is you start with a sketch. So what I want to do, since this is going to be an L-shaped bracket, is I'm going to create a sketch on the side, on what would be the side plane of the bracket. So that'll be this sketch right here. So I go here and I tell it that I'm going to create sketch, and I select the surface or the plane that I want to make the sketch on. And so you can see my units here are in millimeters. Now it's not super important at this point that I get everything exact, and you'll see why. So what I'm going to do now is I want to start sketching some lines. So you can go here in the menu and select line, or you can use the L key. All right, and I'm going to just start right here, and I'm going to go and I'm drawing. You can see it shows you the dimensions of the line that you're creating, and you just keep going and connecting lines, and I'm just clicking on each end point. Okay, so now I've completed a sketch profile, and you'll notice that everything is blue, and what that means is that it's an unconstrained sketch. Now that's important because this type of CAD or 3D modeling, but whatever you want to call it, is parametric modeling, and that means that this object is going to be defined by a series of parameters or dimensions, and I don't have any on there yet. So if I were to modify this, it would not hold its shape, which is typically what you want when you're adjusting dimensions on something. So in order for me to constrain this thing, I need to add some dimensions. So I'm going to just hit the D key, and now I can go along here. I can tell it that I want to put a dimension on that side, and that's fine. I don't really care yet exactly how big it is. We'll make that 5 millimeters. That's good. Okay, now we'll put another dimension here. Just hit return. Same thing with this. Okay, now I have essentially dimensioned this entire L bracket, but you'll see that it's still blue. Why is that? Well, because it's still floating in space. It's not attached to the origin, which is this dot right here. So I need to do that in order to make it have an actual location in space. All right, now you can see that part of it has turned black, but part of it is still blue. That means that the parts that are still blue are yet to be constrained. So what I'm going to do is I'm going to pick a constraint. I'm going to hit the escape button, and I'm going to go over here and I'm going to pick constraints. What I want is a coincident constraint. So I click on that, and I'm going to make the origin coincident with that line. Okay, now what that basically just told it is that this bottom edge of this L bracket must pass through that origin, and now you can see that the entire sketch is black. That means that it's a fully constrained sketch, and ideally that's what you always want. Yeah, you can create things without fully constraining your sketches, but trust me when I say that's just sloppy modeling. And as you will see if you get into this, good modeling habits make a lot of difference, especially as your models get more complex. You get further down the road, you start trying to make modifications to them. You come along a week later and discover that a hole is in the wrong location. You need to adjust it. If your model crashes, it's because of you using sloppy modeling practices. So if you're going to get into this, you just have to get used to the idea that these sketches need to be well constrained. So once you've done that, you just go here and you go stop sketch. All right. So now you can see in 3 dimensions that I have this sketch. All right. Now if I want to turn it into a solid object, what I have to do is go here to create, and I want to extrude that thing. So now it wants to know, what is it that I want to extrude? I want to extrude this profile. All right, this is where it starts to get fun. So now, how far do I want to extrude it? Well, how wide does the bracket need to be? All right, let's say let's say 35 millimeters. That's fine. All I was doing was grabbing and dragging this arrow right here. I could have just as easily entered the dimension there or over here, but dragging the arrow is a lot smoother and faster. And I'm not going to explain all of these individual little boxes here. That just gets into way too much detail. But suffice it to say, now I have created this little bracket. Okay, so super cool. Now let's say that I want to put I'm going to need a hole in the bottom of it right here on this face. Okay, so there's a couple different ways that I can do that. I can go here and I can create a hole, but that's a good way to do it, but I'm going to show you the basic bulletproof way of doing it. We're going to create another sketch, and this time it's going to be on this surface. Okay, so now see it automatically rotates to the orientation that allows me to look straight down on that surface. I want to create a circle, so I hit the C key, and I'm going to just create that, and I don't know how big it needs to be. Let's call it 10, so I'm just typing in 10 millimeter, and there we go. I have a circle there, but you can see again that it's totally unconstrained, so I'm going to hit the D key. I'm going to dimension from the center of the circle to that edge, and let's make it a nice round number of 15. All right, then I'm going to go from the center of the circle to this edge, and again we'll make it, let's see, that was 35. We want it to be in the middle, so 17 and a half. And now you can see that the circle is completely constrained. So I'll stop sketch, and I'm ready to now go here, and I want to create an extrusion. Again, now you may say, wait a minute, how is it going to be an extrusion if it's going to be a hole? You'll see. All right, so I'm going to select that profile. All right, now look right here at my operation. It can be a new body. If I did that, I would have a little cylindrical nub sticking out of that surface, and that's not what I want. I want to make it a cut. Okay, now I'll just take and drag that arrow the opposite direction. Doesn't really matter how far as long as it goes all the way through. Say OK, and boom. Now there is a circle in that bracket. Okay. Now, if I want to clean the bracket up and make it look more dope, let's say that I need to put some fillets on it. Okay, so I go over here, fillet command, all right, and let's say I think I probably need a nice radius on the inside of that corner. How much of a radius? Let's say 2 millimeters. Okay. And it'll show you what it's going to look like. And you can rotate it there, and I'm using this on a Mac, so that's one of the great things about this is that it's because it's web-based, you can use it on any platform. But the reason that I mentioned that is because my controls don't work exactly the same as yours might if you are on a PC. But let's make it a 5 millimeter radius. That looks more cool. So there we go, 5 millimeter radius. Now let's say I want to put a radius on these outside corners. So I'll go back again, or I can just hit the F key for fillet. And I'll click that one, and I'll click that one, and I'll click that one, and that one. Whoops, don't want that one. Let's unselect that, then reselect that edge. And I want these to be 3 millimeter radii. So, and then I'll click OK. So there we go. That is a neat little bracket. It's obviously going to need I think it's going to end up needing a slot in this face. So let's do that real quick. That's a little bit more challenging. Okay, let's create a sketch on this face here. Now this is going to need to be a slot. So I think a good thing to start with is a rectangle. So I'm going to hit the R key, and it's going to let me automatically define a rectangle like that. I don't think that one's going to work. So I hit escape to get out of that. Needs to start a little further down. Whoops, don't do that. R key, start a little further down and do that. Oops. Okay, and click. So now I've got a rectangle of some arbitrary size, but it's going to be a slot for a screw, and so it needs to have a radius on the top and the bottom. So I'll go over here and I'm going to sketch an arc, and I'm going to go from center point. All right, and it kind of knows that I want that center point to be in the middle of that line segment. So I'll click there. Okay, then I'll click here, and again, it's going to kind of help me out. It knows that I probably want it to intersect my rectangle along the sides there. Okay, so same thing here. Click the center, click here, click over here. Okay, now I have some extra line segments that I need to get rid of. So hit escape, get out of that mode, hit T for trim, and I'll click that, and I'll click that, and those now are gone. Now I got a little warning here. You don't have to worry about that. That just means that some of the constraints that were there when I created the rectangle are now gone, but that's no big deal because I'm about to constrain this thing with some dimensions. So I'm going to dimension from the center to center of the arcs. I'm going to give it a radius on this arc. That's pretty good. So now the slot itself is dimensioned, but it needs to be constrained relative to the bracket itself. So we'll do that. That needs to be 17.5, so it's in the middle. And you can see that you have to do a little bit of math sometimes. And that can get sort of frustrating for people who aren't really used to it. But that's just the nature of parametric modeling. And that's what differentiates, I guess you can call it, engineering from just freeform modeling like you might do in something like ZBrush or Rhino, where all it has to do is kind of look like the thing. Now, I've got a little bit of a puzzle here. What have I failed to do? The thing is not completely constrained. Oh, it doesn't understand that these arcs are going to be the same. That's one thing. So let's do this. Equal constraint, and we'll click here, and we'll click here, and now those two knows that those arcs are the same, so that's good. All right, now it's got these symbols here. Those mean, as you can see, that those are horizontal or vertical, but it does not know that they are equal length. So let's also use the same equal constraint. And oh, still didn't get it. They're parallel. They have to be because they are both vertical. So why are they not? Let's see. Maybe we need to make sure that they are tangent. That might do it. There it is. So you can see that this sort of gets into, you have to do a little bit of problem solving. The reason that thing wasn't fully constrained was because it did not understand that the arc and the line had to be tangent. So once I told it that, then it's fine, and now the whole thing is black, and that's a fully constrained sketch. You can keep adding constraints. I can keep telling it, okay, those have to be constrained. And if you get too many constraints on there, it'll tell you that you're overdoing it. See, sketch geometry is over constrained. Basically, what that means is that mathematically, this is sufficient. You don't need that additional tangency constraint. So, at any rate, that's constrained. Now let's create, let's go here, create an extrusion. But, of course, it's actually going to be a cut. and it needs to go through it that direction. Okay, and there we go. There's a bracket with a hole and a slot. All right, and I'm going to stop there because I think that's a pretty good overview of what it takes to create something. It can get obviously way more complicated than this. There's a whole bunch of things that you can create, and we could spend a long time going through all these menus. But again, that's what YouTube is for. There are thousands of hours of video tutorials on YouTube that will help you out, and the software itself is pretty helpful. Like you can see, well, it tells you what a thread is. I mean, you know what a thread is, but you can see that it gives you a little bit of help. Like what's a loft? It shows you that it's the joint surfacing between a couple of profiles, a sweep. All right, you take a profile and you sweep it along a path. So the software itself is going to help you, to figure out how to use all these tools. But all I really wanted to try and show you guys with this was just a little bit of the basic methodology for creating parts, because that's where it all starts. Okay, of course, after I started editing this thing, I realized that I had forgotten to tell you guys one of the most important things. I talked about how it was important to use good dimensions and have a constrained sketch so that you could modify the thing later on if necessary, and then forgot to show you how that happens. So I want to do that real quickly. So let's say that we've decided that this bracket needs to be taller, okay? So if I click down here on my feature tree, okay, I've got each thing that makes up this body, and the sketch being one of them. So let me just double click that, and it puts me back in sketch mode. And let's say that I need to make it taller. So now let's change this from 55 to 70. Okay, so there you can see I've changed the height of it and nothing else has been affected. That's what you want. That's the only thing that I wanted to adjust. And so now you can see that the height of the bracket has been changed, but my slot is still in the same spot. Now that may be okay, but chances are that the slot should really move with the height of the bracket. So let's do this. Let's undo this change that I just made. Okay, and let's go into the sketch that defines the slot. Hold on, I'll get us there, I promise. Okay, so now instead of dimensioning the slot to the base of the thing, let's delete that dimension and let's dimension it to the top edge. Okay, so you can see that it is still constrained now. Everything's still the same, but now it's referenced to the top. So this time if I go and change this to 70, now you can see that the slot traveled with that top edge, which, yeah, is probably what I want. So that's good. But now let's say that I want to change the width of this thing. So let's go here to the extrusion, and you can see now it goes back to this point, and I've got it at 35. Let's say that I'm going to make it 40. Okay, I had some kind of a WTF technical problem there and had to restart QuickTime. Anyway, so you can see that this is now goofy because I've changed the width of the thing, but the holes in the slot are now no longer in the center because they're dimensioned to this edge, so they traveled with it, and that puts them offset. So if I wanted to fix that, I would have to go in and redefine those sketches so that these dimensions were changed. And so I would go here to that sketch and just change that dimension to 20. That's half of 40. And that moves that hole over to the middle. So we don't have to go through all that. Okay, so there you go. Hopefully you found that useful. And if you've even been considering doing this, it gives you an idea of what you're up against. I know it can be intimidating, and the learning curve is kind of steep at the beginning. But as I've said, there are thousands of hours, literally, of really, really good tutorials on YouTube. There's a guy named Lars Christensen who is fantastic. He does lots and lots of videos showing how to use Fusion 360. Autodesk themselves have free webinars that you can sign up for if you really want to get into it. And there are, what was I going to say? Anyway, I forgot where I was going with that. But the bottom line is super easy to learn how to use it. Oh, Facebook group. There's a really good Fusion 360 Facebook group as well where people can answer your questions. So no shortage of resources on how to learn to use the thing. It's free. It makes it possible for you to 3D print just about anything. So why would you not want to check it out if you're at all interested in building your own parts? So I'll shut up now. I think that's about all there is that I can really say at this point. So if you found this interesting and useful, I definitely appreciate you watching. As always, much love.